Welcome back, ladies and gentlemen. We're looking at 4.5 day 1, graphs of sine and cosine now. We're going to be determining the amplitude, period, and phase shifts of sine and cosine graphs. We'll get to what those mean in a little bit. But if we go ahead and graph sine and cosine on our calculators, it gives us things that look like those two things below. Okay, notice we do have a nice wave pattern to them. Those of you taking physics, that probably means a little more to you. But anyway, those what those guys look like. Let's move on and talk a little more in detail about them. Alright, there's a few vocabulary terms associated with these wave graphs, and let's get to them. Alright, I'm going to do them not in the order left to right or anything, but here we go. Okay, the crest. Okay, the crest of a wave is, maybe hopefully as the name implies, the top of kind of one of your hill things. And if you think about hill crest, there you go. Alright, the trough, on the flip side, is the bottom of, I guess, a valley. So you think of the valley as a trough, and hill as a crest. Alright. In mathematics, on occasion we're going to talk about the midline. That's going to be helpful for a few things that we do here. And the midline, as the name implies, is the center line, I suppose, that cuts the thing in half. Alright, another thing we want to talk about is the period. Now, the period is basically the distance from one trough to the next. So there's the period right there. Or alternatively, we could do the period as the distance from one crest to the next. Okay, now those two distances will be equal, so basically the moral of the story there is you can measure it from either trough to trough or crest to crest and you'll get the same answer. Alright, now notice that the period is basically where the graph starts repeating itself. So if I start in the bottom of a trough here and go up to the top and back down, I hit the bottom of the trough, and as I keep going I'm just repeating what I just did previously. So the period is how long it takes before it repeats itself. Okay, the last word over here is amplitude. The amplitude is the distance from the midline down to either the bottom of the trough or midline up to the top of a crest. Okay, now those are distances, so we're going to call them positive every time, but amplitude is either measured there or there, and just like period, no matter where you measure it, it should be the same answer. Alright, now the phase shift is going to be any sort of horizontal shift that we have. Okay, and then the vertical shift, well, the vertical shift will be whatever vertical shift we have. I know that might be earth-shattering, but there it is. Okay, for those of you who would appreciate it, I'm going to write duh right there. Alright, anyway, and we call graphs of this sort periodic since they repeat the same cycle over and over and over again. We've got a period to it, so it's a periodic graph, but yeah, because it repeats itself over and over and over infinity. So there's a whole bunch of vocab. I know that was a lot all at once, but there it is. Alrighty, a minute ago we saw that the graph of sine is a wave shape. Basically what I've done here is I put a nice XY chart that includes the various angle measures that are nice, x, and then the function values you get out of it for the y. Alright, before I go too much further, it is important to realize the square root of 2 over 2 is approximately equal to 0.7, and the square root of 3 over 2 is approximately equal to 0.87. Alright, so I got some decimals that are a little bit less than 1 for all these various square rooty looking guys there. Okay, another thing right here is our vertical lines. Each one of these vertical lines is actually a pi over 2. So this is pi over 2, this is pi, this is 3 pi over 2, etc. 2 pi right there. Okay, and then each of the ones in between are actually a pi over 12. So right here, I've actually got pi over 6, because we don't have a pi over 12 as a nice one. Okay, the next one is going to be actually my pi over 4. The next one over there is going to be my pi over 3 increment. And then over here would be basically 5 pi over 12, which again we don't have a nice value for. So basically this line right here and this line right there we don't have a good value. And of course here we have a pi over 2. So those values kind of repeat throughout here. Okay, so here's what the graph looks like. Okay, if I have 0, I get 0, so it goes right through the origin. Okay, pi over 6, which again is my second line, I've got a 1/2. Well, 1/2, so 0.2, 0.4, 1/2 right there. Gives me a point bar right there. Okay, for the pi over 4, I get a root 2 over 2, which, as a moment ago I said is around 0.7. Next one is 0.87, so that puts me at about right here. And then from there I don't have the next value, but I do have a 1 over there at pi over 2. Okay, if I do that 0.87 again on my next good line that I need, and then my 0.7 again, and then my 0.5, and then again I don't have a good value at this pi over 12-ish sort of measurement, but I do have a 0 right there. and then basically now I have the negative version. So this negative 1/2 is my next one. Sorry if I didn't mention it. Here I'm at 0 already. Negative 1/2 down here. So again, the 7 pi over 6. I skipped the pi over 12-ish line here. Pi over 6 gets me to there. And then I've got myself to a 0.7-ish value, my 0.86-ish value, whatever. And then I get a negative 1 once I get down to the 3 pi over 2 right here. Okay, next value is a 5 pi over 3. Okay, hopefully you've noticed a pretty definite pattern right here. I get to that guy, get my 0.7-ish value, I get my 0.5-ish value. I don't have a very good value right there, and then eventually once I make it over to 2 pi again, I'm back up to 0. Okay, so hopefully you can see that very, very nice wave sort of pattern. I'm sure you don't want to watch me do it, but I could repeat this pattern in the negative direction and get the exact same wave pattern continuing on as many times as I want to cycle through it. But anyway, that is how this graph actually does get its shape if you think about all the nice unit circle values that we actually have. And there you go. There's basically one period of it now. So notice I'm at like my middle line, goes up, comes back down, goes back to the middle line, or kind of starting, and so I'd be repeating myself again. Alright, now here's cosine. I'm not actually going to do this. I just put this in the notes in case anybody wanted to see me talk through this, or in case anybody wanted to see me do the negative version of the sine, I could do that as well. So you've got it there in case you want to see it, but for time constraints I'm not going to do it here in the video. If you want to see it in class, I'll be happy to do that for you. Alright, now I could have gone into much greater detail in those two previous graphs, obviously, but the reason I didn't is because hopefully that was enough to get the idea of what the shape is going to look like, and also that we can do a pretty darn good graph without doing quite so many points, and that's what I'd like to do here. Okay, we can use the unit circle values to quickly draw one of these graphs, either sine or cosine, and I'm going to do both, but here we go. Alright, so if I've got f of x equals sine of x, okay, if I use my unit circle here, and I just drew this one on to help visualize what's going on, alright, my x value is going to be my angle measure. So an angle measure of 0, again the sine is my y coordinate, so in this case 0 as an angle gives me 0 as a function value. Okay, and then really if I just concentrate on the kind of every 90-degree increment, or pi over 2 increment, basically at the top of the circle now, alright, I notice that I've got a y value of 1. So at pi over 2, now I've got a 1. Okay, as I continue around the circle in a positive direction, I get pi, and now I'm back down to 0 for my value. Continuing around, I get to 3 pi over 2, which gives me a negative 1 for my value, so it's about right there. And then I finally make it around to 2 pi, which brings me back to a function value of 0. Okay, so hopefully you can kind of imagine the wave shape there. I can also go in the negative direction to kind of get a second period worth of my graph. And so if I go negative pi over 2, that's just working in a clockwise direction here, and notice it gives me a value of negative 1. Continuing around to be negative pi, I get a value of 0. Continuing around to negative 3 pi over 2, I get a value of 1. Right there. And then finally, working my way negative 2 pi brings me right back to my starting point, and a value of 0. Okay, now if I didn't know this thing looked like a wave, I might draw something that looks like kind of a set of teeth, and I don't want to do that. So again, I kind of know this guy is going to be a wave, so I want to try to do my best to draw a wavy shape and not make it too like triangular looking. So hopefully you can do that. I will forgive you if yours looks a little bit sharper than this. I would love it if yours looks better than this, but anyway, there how you can quickly draw 2 periods worth of a sine graph without too much trouble. Alrighty, now using a similar thought process, we can graph cosine again pretty quickly. Okay, again, just keep in mind now that the cosine is the x-coordinate on the unit circle, and in this case the x is my angle measure, so don't get those two things confused, but here we go. Now if I'm talking cosine, I now have a value of 1 for an angle of 0. So basically my starting point, if you will, for cosine is actually up at 1. Okay, then once I make it up to my pi over 2 rather, okay, notice again the x value now is 0, so now this guy's down here. Okay, once I make it over to pi, my x value is at negative 1. Over to 3 pi over 2 gives me an x value of 0, and then up to 2 pi gives me an x value of 1 again. Okay, so it kind of looks like a V shape right now, but remember it's really a curve, a wave, so I'm going to have something a little curvier than the V shape it's looking like right now. Okay, going in the negative direction, negative pi over 2 gets me an x value now of 0. Negative pi gives me a value of negative 1. Negative 3 pi over 2 is at the top of my circle now, so that's a value of 0 though for the x-coordinate. And then as I make it to negative 2 pi, I get an x-coordinate of 1. Okay, so again, without my knowledge that this thing is a wave shape, I might not draw something that looks very wavy. It might look cartoon teeth. But anyway, here's what my cosine graph basically looks like. Again, that's just 2 periods worth. I could continue this thing for as long as I wanted to, but I think 2 periods is a pretty darn good amount for these graphs. Well, of course, just drawing the graph unshifted is not very exciting, so of course we're going to have to be able to manipulate these graphs around, so let's hopefully remember some of this stuff. So how does the graph of negative 3x plus 2 quantity squared minus 6 differ from the graph of x squared? Okay, well, looking at this, if there's any shifts, okay, remember the guy inside with the x is always lying to you. So in this case, this guy is a shift left 2. Okay, and of course, with the x is a horizontal shift. Any number added or subtracted outside of the x is going to be a vertical shift. So in addition to the left 2 shift, we've actually got a shift down 2 as well. Down 6. Okay, any reflection, okay, now reflection is going to be a basically negative coefficient on your variable. So in this case, this is going to be a reflection over the x-axis. Okay, and then any stretching, which I know is a very mathematical term, but again, if you have a coefficient other than 1, you're either stretched or smashed by that factor. So this is stretched vertically by a factor of 3. Okay, of course, we could have done some other things with the graph, but I think that was a pretty good assortment of things so far. Alright, so using that knowledge about how graphs can get kind of shifted and twisted around, what will the graphs of these equations look like in relation to their unmodified versions, either the sine or cosine without extra numbers in them? Okay, so hopefully when you're looking at this guy, you think, oh, stretch vertically by a factor of 3. So there we go. Okay, let's move to the right. Cosine, I've got this pi over 4 in there. And don't freak out yet, you're going to see a lot of things like that as we continue through these graphs. But right, again, with the x, so there's a horizontal shift, and again, he's lying to you, so I see a plus sign, so that really means I'm going left. So this is going to be a shift left, a value of pi over 4. Okay, this guy got the minus 1. Notice there's no parentheses here, so he's outside of the x, so this guy is going to be a shift down 1. And again, see, he's telling the truth since he's out in the open. And then, okay, this one's a little bit tricky. I've got the 2 in with the x. Now, admittedly, in the case like this, it's maybe not real obvious, but if I put a 2 next to an x, it's implied that that 2 and the x are both together, kind of contained as part of the angle. So what's going on here if I say sine of 2x, again, now I'm kind of stretching in the x direction. But remember, the x is always a big fat liar. So this is going to be kind of smashed horizontally. Okay, and what it does for us is it divides the period by 2. Alright, because again, he's lying, it looks like multiplication, but it's really dividing, and kind of horizontal is basically what the period is. So maybe it wasn't totally obvious before I started saying this, but basically any number on here is a coefficient of the x of the angle measure is going to be modifying the period, and it's always going to be lying. So there you go. But let's come up with some general rules for this mess, because right now that looks a little haphazard now, doesn't it? Alright, so here's our general rules for graphing sine or cosine. Okay, so our format is going to be a times sine, quantity bx minus c plus d, or the same thing, just replacing cosine and sine with each other. Okay, now we've got our amplitudes and our vocabulary again. Okay, now the amplitude again is how far up and down you go from the midline, and that's basically going to be your A. However, amplitude is a distance, so we're always consider it positive. So regardless of A is positive or negative, our amplitude is going to be the absolute value of A. Okay, our period, again, period is kind of how we go horizontally, and so our B value here is going to do that. Now, this is not obvious at all, but the normal period for these guys is going to be 2 pi. And again, this looks like a multiplication, but since he's lying, we have to modify that by dividing. So the original period is going to be 2 pi, but we have to divide off whatever your b value is to get the actual period. Okay, and then a horizontal phase shift. Okay, now the way the book wrote it is the way I put it here in the notes. I like to think of this as a plus, because then my lying and honest thing still works. But the book used a minus sign here, so the formula I'm about to write is based on the book's use of a minus sign here, so don't let that throw you. But the horizontal or phase shift is going to be your C value, but here's something a little bit tricky about this. The B value is actually kind of playing a part. So we actually have to do C divided by B to get that. Okay. One thing, again, it's not totally obvious, but what I like to think of these things as is kind of like the B's been factored out. And if you think of factoring the B out of the C value, it would give you something like this. F of x equals a times sine, and then here's where it gets funny looking. I'm factoring the b out of this quantity, so factoring a b away from bx gives you an x, but then if I factor a b out, I'm really dividing, so then that gives you c divided by the b, and that's why the shift is what it is. Close this bracket up and put the plus d on there, but again, that's kind of the weird thing, and that's why we have to have a c over b. Okay, then the vertical shift is a lot more obvious. It's just the guy sitting out there by itself. So the vertical shift is D, and again, he's telling you the truth, so there it is. But there's your basic set of rules. A goofy modification you could make if you want to, but I kind of don't expect you to, so I'd say kind of run with this, and life will treat you nicely. Alright, homework's going to ask you to do a few things. I can't really do them all because this video would end up being about 3 hours long if I did. But one of the things it's going to ask you to do here, describe the differences between kind of the original unmodified version of a graph and then the modified version based on what you see. Alright, so it's going to ask about the various things here. So let's go. Okay, now between the original guy and the modified version, the amplitude, well, remember the amplitude is always going to be a positive value. So here I've got kind of a 1 coefficient versus a negative 1 coefficient, but since I'm taking the absolute value, the amplitude is actually unchanged. By unchanged is equal to 1. Okay, any reflection, how about that? It's supposed to say reflection, but it says reflection. Let's just pretend you don't notice that. Any reflection, yes, there is a reflection, and there's a reflection over the x-axis. Okay, period. Okay, now again, period is going to be 2 pi, but then I have to divide by whatever the b value is. Now notice in this case the b value is still technically a 1, so our period is just plain old 2 pi. Okay, any sort of phase shift, which is again a horizontal sort of shift, and so here it's again going to be your c over b value, but again you have to think of the c based on having this x minus a number. So again, here's where I think that liar logic maybe comes pretty handy. So it's really a negative pi over our b value, which again is a 1. So either I would accept the phase shift as being just plain old negative pi, or if you'd prefer, and honestly what I prefer myself, is saying left pi. Okay, then a vertical shift. Okay, again, a vertical shift would be a number out here being added or subtracted, and there is none, so none right there. Okay, again, there's a few things that I didn't demonstrate here that do show up on the homework, so please, as always, if you have any questions at all, please ask me in class. See you there.